Hey, this is Brock Mears, and in this video we're going to look at pulse width modulated signals and how you can generate them with the Arduino's built-in capability. All right, so let's start by looking at what a PWM signal is. A PWM is a square wave or a digital signal, meaning that it goes from the lowest voltage to the highest voltage. It's not an analog signal. And what it does is it has a period in which it repeats, which is, you can think of it as like the rising edge to the rising edge or the falling edge to the falling edge. But this would be considered one cycle of a PWM wave. And it has a duty cycle, which is represented as a percentage of the period in which the signal is high. So as an example, if you had a 50% duty cycle, it would be a perfect square wave. You would be high 50% of the time, low 50% of the time, and you would repeat forever. If you had a 75% duty cycle, you would be at a logic high for 75% of the period, then you'd be low for 25% and then repeat forever. And if you had a 25% duty cycle, you would have a little pulse where you'd be high for 25% of the time of the period, and then 75% of the time you'd be at a digital low. And PWMs are really important in motor control specifically because they are how you control a specific type of motor called a servo motor. And that's what we'll look at in this video also. And you can also use them to dim LEDs because the LED, you can basically pulse it at a rate and it will actually dim, and you can save power and get any sort of brightness of an LED that you might want. Okay, so let's start by looking at how you control a servo motor. A servo motor is, they've kind of come up with this standard way of controlling it where you send in a PWM signal that has a 20 millisecond period. And if you send in a duty cycle of 1.5 milliseconds, which is, like 7.5% duty cycle, that will make the motor stay still. Okay. And then what happens is that if you send it a smaller duty cycle, it will turn clockwise. And if you send it a bigger duty cycle, it'll turn counterclockwise. And servo motors can be, a standard servo motor only turns like left and right a little bit. So it's kind of like a windshield wiper. It doesn't actually go all the way around, but you can get servo motors that also spin continuously, and they're called continuous motion servo motors. And so the servo motor that you have in your kit is one that just goes to the left and to the right. So it'll basically, when you look at the servo, it'll tell you the degrees that it'll move. So, usually they're about 180 degrees. They can go from the center position. They can go counterclockwise 90 degrees, then back to zero, and then clockwise 90 degrees. Some of them have a limited angle, like 130 degrees, but that's kind of the basics of a PWM signal. Okay. So now on the Arduino has multiple ways to generate PWMs. And let's look at the servo library first, and then we'll look at the second way to generate the signal. So within the Arduino, there is a library called Servo, which you put in at the top of your code. And then what happens is when you call this function that comes along with it, it will generate a PWM signal automatically for you. You just call it, and it will repeat with a period of 20 milliseconds. Then what you do is you use a command to actually send in the duty cycle in terms of microseconds. So the key kind of parts of using the servo library are, the first thing you do is you do a pound include, and then you give it the servo.h, and that basically brings in the servo library for you to use. And then within that library, there's a whole bunch of functions. Then what you do is you declare a servo name. So this keyword is servo, and you give your particular motor a specific name. And so this helps you if you have like multiple servos. So if you're like, front right wheel or left back wheel or something like that. So it gives you this specific name that you can then write the duty cycles to. And then you can do an attach, which is very important because that's how you basically tell this servo library what pin you're going to run on. on. So in this example right here, this would be like pin 10 on the Arduino. And then when you're done, you can detach it, which means go ahead and stop driving the PWM signal to it. Okay. All right. And then the key function that you use in your program is called write microseconds. So if you write microseconds, you provided an argument that's actually in microseconds. So if you remember, microseconds is times 10 to the negative 6. So to get 1.5 milliseconds, you'd write 1500 as the argument in this write microseconds. Okay. So let's look at an example of how you do this. You set up your servos, and then let's say you called your servo this specific name, Servo SG90, and that's the servo that comes in your smart car kit. And then if you did write microseconds 1500, the servo would stay still. Okay, so hopefully it would stay still. Some of the servos might need calibration, and they'll start kind of like moving counterclockwise or clockwise, and they'll have like a screw on them that you can use a little screwdriver, and you can basically turn it when you're sending a 1.5 millisecond signal to it and calibrate it so that it doesn't spin. Okay, if you wanted to spin it clockwise, you would use this command right here. So you'd do write microseconds 1300, and that would turn it clockwise to a position. And on this particular servo, this is the maximum you want to go. So you don't want to go like send 1000 microseconds, or else it goes out of range. So this represents kind of the range that you can go. And the range goes from 0 to 150 degrees. So it's not 180 degrees on this SG90 servo that's in this kit. And you can go as low as 1000, but you're kind of getting to the edge. If you go further than that, sometimes it'll like start consuming a lot of power. So you always want to look at the data sheet of your servo and make sure you don't go further than this. So for us, 1300 is safe. I've already tested that and it works well. And then if you wanted to spin counterclockwise, here's an example of sending in a 1700 microsecond, or also called 1.7 milliseconds to this one right here. And that's how you would actually control it. So let's code this up on the Arduino and take a look at how it works. Okay, so I'm going to start a new sketch, and here is my my Arduino IDE. And so what you're going to do is you're going to come up, and before the void setup function, this is where you include any libraries you're going to use. So the way that you do it in Arduino is you go pound include, and then you give it open or less than symbol, and it actually comes up with a bunch of different header files or libraries that you can use. But I'm going to type in servo.h, and that then will bring in this built-in library called Servo. Okay, and then what I'm going to do is I'm going to define the name of a servo that's custom to me. So I do this keyword called servo, and I'm going to name my servo something. Okay, so I'm going to call this Servo SG90. And the reason I'm calling it SG90 is because when we look at the little servo in our robot kit, that's just the name of this particular servo. And that then allows me to write functions to that particular instance of it. Okay. All right. So now we come down here in our void setup, and this is code that's going to run once. So what I'm going to do is I'm always going to have like my serial monitor going. So I go ahead and set that up so I can print messages and kind of figure out where I'm at. And let's just do and you got to use the right syntax. And so serial begin, and then let's do print, and let's go testing the servo. Okay. So return. All right, so we should see that message go one time. And then now we're ready to do some of the commands that are built into the servo library. So the first thing you want to do is you want to do the attach command or attach function, and that tells it where the servo is going to be connected. And we're going to do servo SG90, that's the name that I gave it, and then you go dot and you say attach. And I'm going to put this on pin 10. And the reason I'm doing pin 10 is because if you attach the expansion shield that comes with this robot kit, that's where it's routed to. We're not going to use the expansion shield right now. We'll just wire directly into pin 10 on the Arduino board. But that's the rationale for why I chose pin 10. Okay, so then there's pin 10. And then what I'm going to do is I would like to start off by putting the servo into its center location. Okay, so what I'm going to do is I'm going to do this. I'm going to do a print statement that's called serial print, and then I'm going to indicate to the serial monitor what I'm doing. So I'm going to say moving servo into central location, or let's say position. Okay, position. Okay, and then we'll go return, and boom. And then now I'm going to do my write microseconds. Okay, so I'm going to go servo Okay, servo SG90 dot, and now this is the function to set the duty cycle. So I go right microseconds and I say 1500 microseconds, which is 1.5 milliseconds, and this will start up and it will put it into the center location. Okay, so now down here in the loop, we can change things around. But at this point, why don't we go ahead and let's save our program and then let's run this and let's take a look at this at the actual PWM waveform that comes out of this. So what I'm going to do is I'm going to say save, and I'm going to put this into where I've been working, which is on my desktop here. So I go to desktop and sketches, and I'm going to name this 03, and we'll call it PWMs. Okay, and we'll go ahead and save that. Okay, so at this point, I'm ready to compile and verify. So let me verify the code and make sure I don't have anything on here. And notice I didn't detach this. It's good coding practice to detach it at the end, so I should have done that. So, okay, we're done compiling. So it's time to connect the Arduino. Okay, so I'm going to come over here and take my little Arduino UNO R3, and what I'm going to do is I'm going to plug in the USB cable. That gives it power, and so now I'm up and running, and I'm now going to download my program, and I noticed that it found Arduino UNO on COM3, and that's because that's what I've been using each time, and so I can go ahead and check that if I go to port, and I notice COM3 is the only one that has an Arduino on it, so I'm good to go there. So I go ahead and download this. And we're just going to download this and make sure that the serial monitor is up and we can actually see our text being printed. And then from then on out, we should be able to measure the signal. So I'm going to come up here. It's running now. I'm going to come up to Tools and then go to Serial Monitor. And I should see the message printed, okay? So I see testing the servo, moving servo into central position. And if I want to verify that that actually is real, I can hit the reset button and it'll run again. So I go, okay, there it is. So at this point, there is a PWM signal with a 1500 microsecond or 1.5 millisecond duty cycle that's on pin 10 of this device. And this is the servo that we're going to connect at some point. But what I want to do first is I want to look at this with an oscilloscope and make sure that the PWM is actually there. So I'm going to use this analog discovery, and I'm just going to connect up the oscilloscope to pin 10. And so let's get a couple wires here and connect it. So I'm going to have to get a ground from the analog discovery. Let's see here. That on the screen. So I got my ground right here, and then what I'm going to do is put this into there, and then I'm going to attach this to the ground, and I want to be very careful when I do this. So I go over to ground. Okay, so I got my ground, and then what I want to do is I want to take the oscilloscope channel 1, and I want to take that and attach it to pin 10. Okay, because that's where my PWM will be coming out. So I come over to here and I do pin 10. Okay, so at that moment in time, I should be able to measure the actual PWM signal. Okay, so now I'm going to bring open the analog discovery oscilloscope tool that's called waveforms. And what I'll do is I'll launch a scope, and I'll go ahead and hit run, and then I'll configure my trigger on here. So something's happening. So I got this signal running on here. And so what I'm going to do is I'm going to move it down a little bit so we can see it better. And then I want to move the trigger up, and then I'll turn off channel 2, and you can kind of see something's happening here. So let me turn off channel 2, and then I want to zoom out, and it's like, oh, that kind of looks like a square wave right there. Buttons on here are a little small just due to the way that the laptop display is, but let me turn it to 2 volts per division, and holy moly, I got myself a PWM signal right there. That is pretty cool. Check that out. Now, how big is it? Let me attach a measurement tool. I'm sorry about how small this is. Pulse. So what I'm going to do is I'm going to drag this down there, and I pop that in there, and if you are, let's see, so I want to pull it over to here, and if you can see 1.5 milliseconds right there. Let me do this. You ever use this magnifier tool? Here's the magnifier tool. Let's see if I can even. So see how it says 1.5 milliseconds, and then the period is 20 milliseconds. I know that's hard to read, but anyway, that's kind of cool. So what this proves to us is that this is actually producing a PWM signal. So what I'm going to do is now I want to play around with changing the duty cycle in real time using my code, and I'll leave this oscilloscope up, and let's look at what happens when we kind of get into our main loop and then we change it. So I'll kind of go like this so you can see that scope running in the background. And so what I'm going to do is I'm going to come down here, and in my main program, what I'm going to do is I'm just going to copy and paste this right here because I already wrote it. And so let's move this over to the right position. Okay. So let's move servo into right position, and we'll write 1300 to it. Okay. And now I gotta verify that that's correct. So we'll know when we do it because if it's not in the right position, it's the left position. And then what I'm going to do though is this will put it into the center position. And then what we're going to do is we're going to move it one way, and let's verify that that's correct, right? Yeah. So if you send 1300, it'll go into the clockwise, so the right position. So if you think about this, this sends a signal out and it's going to move over there. Okay. And then we want to delay a little bit so that we can actually see it move. And then we want to send another command to it. So what I'm going to do here is I will say, okay, move it to the right position and then wait for a half a second using this delay function. Okay. And then what I'd like to do is let's move it back to, let's move it to the left position. All right. That ain't hard to do. Actually, no, let's move it into central position by writing 1500 and then delay again. And then let's move it into the left position. Okay, so copy and paste again. And so now I'm going to move it into the left position by writing 1700. And then when it repeats, we want it to go back to the central location. So this is just going to move back and forth over and over and over. Okay, so I'm back into central position, and it will spit out what it's doing in the serial monitor, and we should be able to see it actually move in the oscilloscope here. So I'm going to download this. So let's see what happens here. Okay, so now it's running, and let's zoom in on this and see what's happening. Oh baby, look at it! Look at it! See what's happening here? So it's going, okay, central, left, right. So it's going 1.5, 1.3, 1.5, 1.7, 1.3, 1.5, 1.5. So it's basically going through these, and it's going to left position, central, right position, central, left position, central, right position, central, left position, central, right position, central. And it is actually doing what we expected it to do. So this is phenomenal. And if I wanted to make it more kind of intense, I could actually come in here and go ahead and go to 1,000 and then take this up to 2,000, and hopefully this won't break it. But let's take a look at that, and then let's attach something to this guy and see what happens here. So, oh boy, look at that. Now here it goes. Look at that. That is really noticeable. And let's get a couple of these on the screen so you can actually show that it's repeating over and over. And it's like, oh baby, oh baby, oh baby, oh baby, oh baby. Okay, there it is. All right, so now let's connect something to it and see how that works. All right, so I come back over here and I'm done with my oscilloscope, so I can go ahead and pull that out of there, and I'll go ahead and disconnect all that. And you can see on the screen it goes away, so I'll put the old oscilloscope aside for a second. Try not to bump into anything. And let's go ahead and close waveforms. And no, I don't need to save that. All right, so now I got my thing. I got my Arduino, and here is the servo. Okay, so you can see right here, this is the micro server SG90 on there. And the way that these work is you have a ground, a power, and a control signal, and they're color coded. So the brown is ground, should be black. Red is power, that's good. And then, I don't know, orangish yellow is the control signal. And so servos are really nice because you provide power separately from the control signal. And that means that the control signal can just be directly connected to a digital signal, okay? So I went and grabbed I grabbed 3 wires out of my wiring kit that have the male on both ends. And lo and behold, the color coding just happens to match. I doubt that was by accident. So when you connect this up, you don't want to, since you're going to be touching power, and you're going to be drawing power from the Arduino. You don't want to do it while it's live. So let's go ahead and depower the Arduino, and then we'll go ahead and plug these guys in first. And what's cool about it is the program's already on there. So once I fire this up, it will still be on there. So I stick that in there. Red goes next, and then ground. Okay, so I got my, make sure those are right. Yellowish, orange, red, and then brown, which should be black. Okay, and now what we're going to do is we come over here and let's start with ground. So I'm going to take the ground lead and go into ground. My power, I'm going to go to +5, which is where is +5? Actually, let me get the powers on this side so I can tip that up, and I got myself a ground. Boom, boom. I want +5, which is boom, boom. Right, and verify that that's right, because those are important ones. And then we come over to pin 10, which is right there. And there we go. Okay. So now, if I just plug this back in, the program's going to start running. It should actually start moving. So, nope. Okay. Oh boy. Check this out. Okay. So, and you can see the serial monitor going too. So it's like, okay, right, left, central, left, central, right, central, left, central, right. Central, left, central, right. Isn't that awesome? So that is awesome. And all you're doing is doing it with a servo or with a PWM signal that's automatically generated. And this just goes and goes and goes. And you did it. And so this is sweet. Now this is like a windshield wiper application or like moving a sensor back and forth. This servo isn't continuous motion, but there it is. You did it. Now how awesome is that? All right, that is it. You did it. Nice work, and we'll see you.